Hello, my name is Riccardo Scandariato and welcome to Advanced Software Architecture. This video lecture is on Quality Requirements Part 2. In this Part 2, we focus on the second goal for this group of lectures, that is, understanding and characterizing software qualities. Let's address the second goal of this lecture, to understand and characterize software qualities. Let's begin our tour of qualities. We will examine three classes and they are listed according to their importance in this course. A good deal of attention is given to software and system qualities, like for instance performance, availability, security, and so on. They will be covered in detail in the next slides. It is also important to be aware of the existence of business qualities, such as cost and time to market. These qualities are also directly affected by the architecture, although they are not about the software product itself. There are other qualities that are about the architecture itself. Such qualities are, for instance, conceptual integrity and buildability. For instance, conceptual integrity refers to the underlying vision that the architect has injected in the design, for instance, by selecting similar solutions to similar problems throughout the entire architectural design. These are important, but they will have less focus in this course, and they are mentioned now for your information. Requirements can be divided into functional requirements and quality requirements. Functional requirements specify functions that are offered by the software system, and such functions are characterized by certain attributes. Let's pick an example. For instance, a web application that has a portal. In this case, the offered functionality might be the ability for customers to browse the catalog of items on sale via the portal, and the attribute would be the amount of customers that can concurrently access such portal. Quality requirements specify constraints on such functions. For instance, in our example, a performance constraint would be that, for instance, we are interested in having at least 1,000 concurrent customers. So what is important to note is that the nature of quality requirements is that of being constrained, expressed in a measurable way with respect to certain functions. In a coarse-grained way, software and system qualities can be organized into groups: runtime qualities and development time qualities. Runtime qualities, like performance, availability, security, and so on, are related to the system behavior, while development time qualities, like maintainability, for instance, are related to the development process. The previous definition of quality requirements is mostly related to the runtime qualities. Different engineering communities have different terminologies when referring to qualities. In this respect, standards come to the rescue by providing a taxonomy of qualities and by providing also well agreed upon definitions. One such standard, for instance, is the ISO 25010, which is shown in this picture. Here are some examples of quality attributes that we cover throughout this course. Availability defines the proportion of time that the system is functional and working as expected. For instance, it can be expressed as the percentage of the total system downtime over a predefined period of time. Performance is an indication of the responsiveness of a system to execute a functionality within a given time interval. Important sub-concerns of performance are, for instance, latency and throughput. Latency is the time taken to respond to an event, while throughput is the number of events that the system can service within a given amount of time. Security is the ability of a system to prevent malicious actions, so the actions of an attacker, and to prevent the disclosure or even loss of information. Testability is a measure of how easy it is to create test criteria for the system and its components, and to execute those tests in order to determine whether the criteria are met. Usability defines how well the system or the application meets the requirement of the end user. For instance, by being intuitive, easy to personalize, and resulting in an overall good user experience. Modifiability refers to how easy it is for developers to change the system. For instance, to add new features or to fix bugs. Interoperability is the ability of a system to usefully exchange information with external third-party systems. This refers to both being able to exchange the data as well as correctly interpreting the data being exchanged. In the previous slides, we have seen some examples of quality attributes. Let's practice a bit. For example, let's suppose the architect has to make a design choice that will influence how quickly the system recovers from a failure. Which quality attribute is the architect dealing with? A stakeholder is worried with how the system uses processor capacity, disk space, and so on. Which quality attribute is the stakeholder concerned with? The architect is dealing with how easily can the system be updated with new functionality. Which quality attribute is the architect concerned with? If we are discussing about how easy it is to fix defects in a system or to make changes, which concern are we dealing with? If an architect is dealing with a problem of making the system working on different platforms, which concern is the architect dealing with? Can we use some components in this system to implement similar systems in the future? What type of concern is that? How easily can more users or servers be added to the system? What type of concern is that? How can I verify that the system is implemented correctly? Which type of concern is that? This is the end of Quality Requirements Part 2.